Alright, this is your review video for the graphing section of your test tomorrow. So today we have this equation right here, and we want to graph this system and make sure that it works. So remember, there's always two methods. If we have a problem that looks like, if we have a problem that looks like this first one, it's written in slope-intercept form. So we can just graph our slope and our y-intercept. Or if we have an equation written like this, which is in standard form, we can find our x and our y. I'll show you how to do both for the practice, okay? So remember, for graphing, if it says y equals, then it's in slope-intercept form. We have y equals mx plus b. B is my y-intercept. That's going to be my very first point. So right here, my very first point is going to go at a positive 4. Then this one is my slope. I always want my slope to be a fraction. So if it's not a fraction, I'm going to put it over 1. So I have negative 3 over 1, which is rise over run. So I'm going to rise negative 3 and run 1. Well, negative 3 means I'm going to go down instead. So I'm going to go down 3, and I'm going to run positive 1. I can go down 3 more and over 1. Or I can go the opposite way and go up 3 and over 1. Either way, I end up with this line for that equation. The second one, I'm going to do the same thing. So I'm going to take my y-intercept, which is my first point, negative 2. So I'm going to go down to 2. And then I'm going to graph my slope. Again, my slope needs to be a fraction, so 3 over 1. So I'm going to count up 3 and over 1. And I can count up 3 and over 1. And I notice that I have this equation, or this line. This point right here where they meet, that's 1, 1. That is my answer to this problem. Just like that. That's if we have slope-intercept form. Remember, if we don't have slope-intercept form, we have x and y and a number, we want to solve for it. So we take just the x's, so 4x equals 2, and we solve this, divide by 4, and get x equals 1/2. This is the point that's going to go on x, so right at 1/2. Then we're going to do the same thing for y. We're going to put y equals, and then 2. Well, there's no solving needed, it's just y equals 2. And then we're going to connect those dots, and that's going to be my line for that one. We're going to do the same thing for the bottom one. We're going to have x equals 3. So on x, we're going to put a point at 1, 2, 3. And then on y, we have negative y equals 3, which means y is going to equal a negative 3. So we're going to go down 1, 2, 3, and we're going to put our point there. We're going to connect the dots. And we notice that it's not exactly on a mark. It's kind of off a little. If I drew my line straight, it's still kind of off. But we want to, again, think about what that point would be. The ones on your quiz hopefully won't have fractions, and so there'll be a nice even number or whatever. That's how we graph. So again, go back, look through your graphing section, make sure that you understand it. There's one other thing that you need to remember with graphing is we might have possible answers that aren't a point, right? If I have a line here and then another line here where they do not intersect, remember that is no solution. Okay? And then if I have a line right here, and then when I draw it, a second line goes right on that same spot, then that's infinite solutions, meaning every number works. And then, of course, if I have a line here, and then I have another line that crosses right here, and it intersects at that exact one point, then whatever that one point is, 1, 2, 3, 4, 5, 6, 7, 8, negative 8, 0, would be that one solution. Okay, so again, remember on your test tomorrow, there's going to be a section where you do have to graph and tell me what the solution is. And again, those graphs could be infinite many, or it could be no solution, or it could have one solution. And there will be a section on your test where it will ask you to just draw a picture of what those answers look like. So again, remember, no solution is parallel lines. Infinite solution is the exact same line on top of each other. And then one solution is that just one point where they intersect.